Hello everyone! Today we're going to explore a fundamental concept in modern software development, object-oriented programming or OOP. If you've ever used a smartphone, driven a car, or even made a coffee, you've interacted with real-world objects that can help you understand OOP. So let's get started by understanding what object-oriented programming actually is.
Object-oriented programming is a programming methodology that makes the code manageable and scalable. We use object-oriented programming to make a more organized code to model real-world entities using objects.
Each object has attributes and behaviors where the attributes is like a name of a student, the color of a shirt, or a size of a coffee. And behaviors are walking, turning, and opening. And these objects are built using classes which are like blueprints.
An example of this is a child that inherits his or her eyes to his or her mother. However, the child's lips and hair is inherited by his or her father, but the child can also have its own unique features. Procedural programming is a programming approach that focuses on a step-to-step to solve a problem. In procedural programming, functions and data are separate. The code is also reusable through functions.
An example of procedural programming is a recipe that follows a sequence of steps to cook a dish.
Alright, in this next part, we will walk you through two short code examples. The first example demonstrates a procedural programming style focusing on functions and sequences.
In contrast, object-oriented programming is structured around the objects that model real-world entities. OOP or object-oriented programming combines the attributes and behavior into one unit. The main focus of OOP is to model real-world entities using objects and how they interact, also about how they behave. Code is reused through inheritance and polymorphism.
An example of object-oriented programming is a restaurant system where each chef or object has their own tools or data and methods as actions but works together as a part of a restaurant or a program.
Okay, now let's jump into the second example that uses object-oriented programming where we define classes and objects to organize our logic.
Object-oriented programming has the most advantages over procedural programming. OOP makes the program more organized, easy to update, reusable, and manageable. This allows us to reuse the code through classes and inheritance, reducing duplications of data.
Let's now dive into the four core principles of object-oriented programming. First is encapsulation, or protecting the data. Encapsulation is the concept of hiding internal details and only exposing what's necessary. It protects the data by keeping it private inside the object and only allowing access through public methods. A real-world example of this is a vending machine. You press the buttons, which are the methods, to get a snack, but you don't know or need to know how the machine works inside because it's hidden or encapsulated. Encapsulation means keeping the data and methods safe inside an object. It is also known as data hiding. It's done by declaring instance variables as private and methods as public. Getter or accessor returns the value of a private instance variable. Setter or mutator updates or changes the value stored in a private instance variable. Second is abstraction, or hiding the complexity. Abstraction is about hiding complex logic and only showing the essential features of an object. Think of driving a car. You turn the steering wheel, press the accelerator. You don't need to know how the engine works, just the interface to drive it. Next is inheritance, or reusing code. Inheritance allows a class to inherit properties and methods from another class. It supports code reuse and hierarchy. Think of a family tree, where a child inherits some characteristics from their parent. The existing class is called the superclass or parent class, while the new class is called the subclass or child class. This concept promotes code reuse, organization, and makes it easier to extend or modify programs. Lastly is polymorphism, or same interface, different behavior. Polymorphism allows one interface to be used for different data types or classes. It lets us use the same method name but different behaviors depending on the object. A real-world example of this is the start button on different devices, like on a microwave, it hits food. On a washing machine, it starts washing. It is the same interface but different behavior.
That's it. Thanks for watching.